that was just to explain the slope of the indifference curve, the marginal rate of substitution and all. So now we'll be looking at the budget line. This is the equation of the budget line. That's m is equal to xpx plus ypy. M here represents income, x is a good, px is the price of good x, y is a good, py is the price of good y. So the slope of the budget line now, you make y the subject of the formula to get the slope. So we have ypy equals m minus xpx. So you divide through by you divide through by py to make y the subject of the formula, because we are trying to get the slope of the budget line. So we have to make one input the subject of the formula. So that's y is equal to m over py minus xpx over py. So to get the slope, you differentiate y as usual. So we'll have dy dx. You differentiate y with respect to x, because slope basically signifies change. So that will be dy dx equals, since you are differentiating with respect to x, and this part does not have x, so it will be cancelled out. So you have, when you differentiate this with respect to x will leave. So that's minus px over py. So this is the slope of the budget line. Px over py is the slope of the budget line. Yes. So now we'll be going to examples. These are just basic things to understand, like concepts, because without understanding that, you may not be able to solve some questions. Okay, so we'll be solving an example. Another thing I want us to note is that when I was explaining the consumer theory, I said that consumers are rational, and rational consumers will always want to consume, they will always want optimum consumption. That's the best consumption. And optimum consumption happens when the slope of the budget line is equal to the slope of the indifference curve. And we already established that slope of budget line is px over py, and the slope of the indifference curve that's the marginal rate of substitution, which is mux over muy. So this is when consumer is at optimum consumption. So now let's look at an example to explain all this gibberish. So u is equal to x raised to power half, y raised to power half, and then we have m is equal to 1000, px is equal to 5, and py is equal to 2. So I'll teach us what we're meant to do in like exam conditions, but after that I'll teach us like a straightforward answer which we can use like if it's OBJ question. So when we see a question like this and they tell us derive the optimum consumption or the derivation of MRS, and what we do is introduce Lagrangian function, and you can, so this is the, okay, sorry, you first write out your budget line. That's m, our budget line is m is equal to xpx plus ypy. I explained that earlier on. So our budget line here is 1000, equal to 5x plus 2y. So this is the constraints. This is the objective function. So we're trying to maximize utility with a constraint with this budget constraints. So we can introduce the Lagrangian function, which we can write as z is equal to, that's the objective function first, that's x half, x raised to power half, y raised to power half, plus lambda, introduce lambda into bracket the constraints. Okay. So 1000 minus, you bring the 5x and 2y to the other side. So this is what we get after introducing the Lagrangian function, and we can call that equation 1. So you differentiate this with respect to all the variables. So we have change in z with respect to x. So we'll get half x raised to power minus half y raised to power half minus 5 lambda equals to 0. Equation 2. Then change in z with respect to change in y. We have half raised to power x raised to power half x raised to power half y times y raised to power minus half minus 2 lambda equals to 0. Then changing z with respect to lambda, that's equal to, that's just what is here. Just bring what is beside lambda out. Equals to 0. Yes, kind of. So we can bring these two equations together. So that's because both have lambda, so you can equate it to each other. So from equation 2, we have half times x raised to power half minus half times y raised to power half minus 5 lambda equals to 0. And then for equation 3, we have half times x raised to power half times y raised to power minus half minus 2 lambda equals 0. So you can make lambda the subject of formula. So we have half x raised to power minus half y raised to power half equal 5 lambda. Then this half minus half means for 2 lambda. So make lambda the subject of formula. So you have lambda is equal to half x raised to power minus half y raised to power half divided by 5. And from here, lambda is equal to half x raised to power half y raised to power minus half divided by 2. So you can come in. Yeah. So you can now equate the two. So since this is equal to lambda and this is equal to lambda, you can equate it. So that's half times x raised to power minus half times y raised to power half over 5 is equal to, since this is lambda and this is also lambda, we'll just equate them. And now you can cross multiply, or just to avoid confusion, just write it as half y. So this is 1 over 2 times this y raised to power half. What I explained before, that if you have raised to power minus something, you bring it to the under. So times this 5 here, we won't neglect that 5 times x raised to power half. Do the same thing here. 1 over 2 times x raised to power half. 2 times this 2 times y raised to power half. So that's y raised to power half over 10 x raised to power half equal x raised to power half over 4y raised to power half. So you cross multiply. So you get 4y equal to 10x. And then you can make y the subject of formula. So y is equal to 10 over 4x. That's equal to 5 over 2x. So since you've gotten y, sorry about that. Yeah. Since you've gotten y with respect in terms of x, you can now substitute this 5 over 2x for y in the original, in this budget constraints. So we have 1000 is equal to 5x plus 2y. So instead of writing y here, you can just put 5 over 2x. So we have 1000 equal to 5x plus 2 into brackets 5 over 2x. And so that's 1000 equal to 5x plus 2 cancel to 5x. So we have 10x is equal to 1000. Then x is equal to 100. And since y is equal to 5 over 2x, so y is equal to 5 over 2 times 100, which is equal to 250. So y is equal to 250. So the optimum amount of x and y is 100 and 250 respectively for this utility. So this is just an example. Then I'll give another example, then we'll solve a past question.